Just a little bit about while we're getting set up, some logistics of how the workshop will run. It's supposed to last the most 45 minutes. I'm expecting to use about half the time for presentation and demonstration, and then there'll be time at the end so that people can try out our Explore app, put it through its paces, try to break it, and give us some feedback on how you think it works. Also, people online, if anyone's still with us, you can put questions into the Slack channel, which starts with the name, I think, Workshop 2. And Zach has offered to monitor that. And during the end of the session, when people are working with Explore, I'll sort of wander around and see how people are doing, answer questions, and try to monitor the Slack channel. It's displayed. Yep. Almost. Sure, if people want to move a little closer, that would be great. All right, I think we're ready to go.
So you're here and you can switch between the tabs and it's all mirrored. You're all up.
That looks good. And
yeah,
cursor's visible.
I'm sorry, I can't really get rid of
All right, I'll work around.
If you get near there, a window will pop up. So.
All right, I'll try to work around that. Okay, let's get started. Good, okay. So our current proposal and program preparation apps, which is the PIT for proposal preparation and the OT for observation preparation of these, large job applications you have to download to your desktop at least once a semester. They've been in use for over 20 years now. They work as far as they go. We've tried to make improvements to them continuously throughout the years. But a few years ago, we realized that a lot of the usability and functionality that we wanted, we just couldn't put into the current applications. So it was really time to just start fresh. And there are a lot of other reasons because of the age of observatory changes in software that we needed to do some basic updates to our whole software stack. So that led us to the Gemini Program Platform, which is really the core project of an even larger sort of program of projects for upgrading our OCS software, which is Observatory Control System. It's really the high level user interface for operating the telescope, for submitting proposals, and so on. So this is really the core project with the goals of improving usability, making everything easier, especially phase 2s and proposal preparation, improving efficiency through increased automation, supporting time-domain astronomy by providing the frameworks and the constraints we need for an automated scheduler, as well as APIs for better communication, supporting new instruments such as Scorpio and GNAO, and avoiding obsolescence. As I say, we need to sort of modernize our entire stack to make it better, easier to maintain, and a lot more scalable. So what is GPP? It's basically going to be a set of web applications that communicate with databases which live in the cloud via these very secure APIs or application interfaces. And the main applications that you will probably encounter are these set here. This is sort of the diagram of the entire system. As you can see, what you're seeing is just the tip of the iceberg in terms of what we have to build. The main things that most of the community will be using is the browse interface. Oh, sorry, I'm going to start out with the dashboard interface, which is where you go to see, like, you log in, you see a list of all of your proposals or programs that you have access to, and you can switch between them. Then there's Explore, which is probably the main application, will be like the focus of this talk, which is the proposal and observation preparation tool. It's like the main PIT OT replacement. There's Browse, which is a search feature, like the OT browser right now. Then there is Chronicle, which is a logging tool, both used by staff to do the logging, and then users will go to it to get the observing log for your program on a given night. I'll give a little more of that later. And then there is a weather application, because we want to have a weather server that gives a history of all the weather conditions and forecast into the future. Then there's a bunch of internal applications we'll have. We observe is extension of our current web SecExec for actually executing the observations, communicating with the telescope and the instrument. There's resource, which is a telescope and instrument calendar. Schedule is the interface on the automatic scheduler, and an admin window for managing users and other administration features. Then, of course, there's all sorts of other services that we have to build to go with this. You'll see things that you'll notice, like the integration time calculator, something that will automatically look up and select guide stars, calibration managers, and things like that. So it's a very complicated system, a lot of moving parts, but by doing it together as a unified system, we hope that actually be simpler to manage in the future, because right now all of these are very separate, different components built with different technologies, and therefore makes it even harder. Okay, so I'm going to go over something on Explorer first. Before I dive into my demonstration, I want to go through some mock-ups so you can see sort of what we have in mind, the sort of all the features that we are anticipating. You'll see we're not quite there yet. But it's getting there. Okay, so the main layout when you log in, all of the applications are going to have a very similar look and feel, or a very similar layout, so that we're familiar to use. So at the top, here we have an application switcher. There's a waffle icon, like sometimes you get with Google, so you can switch between these different applications and different views. In the upper right is the user identity and authentication, so you can log in just to be able to see your programs. On the left, sort of vertical navigation bar, a set of tabs which allow you different views on the information that you're trying to look at. In the middle is an item tree, sort of the lists of things that you've selected here. And on the right, when you select something to here, and then you get the details on the right panels, of which you can collapse and expand those to see more information. Then in the upper here at the top of the list, there'll be some action buttons for creating observations and targets, groupings. Summary here, and there's a little search box. Because you have a lot of observations, you can shrink your list, focus on what you want. And then at the top here, there'll be some little button where you can actually create a proposal from a new set of observations. So if you add some observations and go to the observation view here, again, we're getting a list of all the observations that are defined. Select one of those, and then all the details of that observation here, the targets and constraints, instrument configurations, and ITC output down there. Add a few more observations, and now you see that in this particular one is for geners. It was automatically created the telluric observations that go with it, and those are linked to it. So as you change an instrument configuration, those are updated automatically. Whereas now that's a completely manual process. So you have to go through and change everything manually. Also, we're going to put in logical groupings. So you can make AND groups to specify observations that have to be done together. Use OR groups to provide options. For example, the GMOS North or GMOS South is fine for this observation. And the scheduler will use that information as part of the scheduling process. Then here on the right was also an advanced configuration. We're going into more specifications on your observation if the defaults aren't quite right. This gives a blow up of that. This looks a bit like the OT instrument component now. So it allows you to do all the settings, like exactly specify the disperser or the binning, or specify your wavelength or spatial vivid patterns if the default one doesn't quite meet your needs. There's also going to be a variety of sort of exposure time modes. So you enter the signal to noise, and the system will automatically run the ITCs and figure out how many exposures and exposure times that are best to reach that. But if you want more control, you can change that so that you can specify, I need 15 exposures to reach the signal to noise, and you'll get the exposure times. or you can specify I need 15 exposures of 300 seconds, for example, to do some sort of time series. So you can specify that exactly if you need to. Then you can switch to the target view. For example, your target tab there. Now you have the list of observations organized by target. So it allows you, if you select, a set of targets or one target with a bunch of observations underneath it, you make a change, you made the same change to all of them. So it's a bulk edit feature. You can also then upload a list of targets. That's a very heavily requested feature. So you don't have to, do a send-out search or type everything in by hand. You'll be able to copy observations and drag and drop observations between targets. Then the constraints view here is the same type of thing. It's the observations organized by constraint set. Again, you select a group of them, you can make a bulk edit to the constraints, drag and drop observations, import lists of timing windows, those observations, and copy observations. Configurations view is the same thing. And now you're organized by instrument configuration set, and you can do bulk edits again on a list that have the same configuration, drag and drop, copy. I think you probably get the idea. Yeah, you can do all of that unauthenticated, just so you can play with the system, see what Gemini has, see if there's something you want to propose for. Once you want to put in a proposal, you have to authenticate. And the goals for Gemini in terms of authentication are make sure that you gain access to the program's proposals of which you're entitled to, that you have permission to access. We want to avoid having to manage accounts and manage all of your email addresses and affiliations, especially as you move around. And we want to keep track of publications based on a given program. And so the ORCID, the Open Research and Contributor ID, is actually perfect for this. It's now become extremely common in astronomy. It's actually required for AAS journal submission. It's accepted by most other journals. It's free. It's really easy to obtain. It takes like 5 minutes, and it's unique to you and follows you. So there's the URL. If you don't have one, you can sign up for it. And it allows ORCID to keep track of all of your, email address and affiliation. You update your profile there, and that information is automatically accessible by Gemini. So once you've logged in, you're authenticated, then you get to open up the proposal view here, and this is going to look quite familiar. Up at the top, you get to put in your co-investigators, and even specify who has what privileges on this proposal. It's just read only, edit, who can submit. So it allows for collaborative work on the proposal. You enter your abstract, request details like how many hours per participant, button to attach your PDF, attachment for the scientific justification. You can export a PDF summary, so you can see sort of exactly what the TAC will be able to look at. You can duplicate a proposal if you need to, take an old proposal for a new semester, be able to do that. And then, of course, there's the submit proposal button. So you submit that. It basically this is just a change of flag in the database, which means that up until the proposal deadline, if you find some typos, you need to update a figure, you just retract that submission, make a change, and submit it again. There's the duplication that you have now. And of course, at the proposal deadline, then it'll lock that. So now that's sort of the design we'll explore. Now I'm going to switch over and try to use it in real time. So if you navigate to it, you haven't been there before, you're going to get a login screen like this. It allows you to either log in with your ORCID or continue. If you log in with ORCID, it sends you to the ORCID page where you put in your NKD, your password, and give Gemini permission to access your information. This is not my computer, so I'm not going to do that right now. I'm going to go back and just work The rest of the demo is as guest. So click on there. I haven't used Explore on this machine yet, so I get sort of the program listing. So I have to select one of those pre-made programs. I'm going to use this first one. And now you get the basic layout view. It's a lot like the first mock-up I showed, where you've got various tabs on the left. You've got user information over here. Again, you can switch programs with that or log in. If I click on the observations tab, I get the list of observations that have been defined. I click on one of those. There's the observation details with the target information. There's a sky survey image. If I scroll down, that's right. This scrolls the opposite way, I think, that I used to. Okay, if I scroll down, there's the rest of the details. There's visibility information and the configuration, which will go over in more detail. Also, I can close these various panels so I can focus on the other bits of information that I want to look at. So I'm going to go ahead and create a new observation. So there's the new observation. Click on that. Now I'm going to add a new target. And to do that, I can just start typing a name. And it's doing a Sinbad query for everything with that name in the title. So I have these options. I'm going to select male 5. It's downloaded the information it can get from Sinbad and brought up the sky survey image, and I can zoom in and out on that using this Aladdin Light plugin. And you see if I go out far enough, I start seeing M31 because this is one of the brightest cloud clusters in M31. So back in more reasonable view. One thing we did not get from Sinbad is the spatial profile in the SED, so I'm going to just change that now. It's slightly resolved, so Gaussian 2 arcsecond full f max, and the SED is more like, again, reverse scroll. It's more like G. So that's basically defined my target. You know, I can continue to go down. Let's just close this for now. To the instrument configuration. So one really important thing about Explorer is that it knows about all of Gemini's instruments and their modes. And so instead of you having to go search through all of our external web page, all the instrument web pages to determine what do we have available and will it work for you, this will tell you what is available. So at the moment, I guess it's sort of behind that, but it says there are about 400 GMOS configurations that match. I haven't really typed in what I want to do yet. So I'm going to enter my science requirements. I'm going to do calcium triplet observing 0.85 microns. And I want a resolving power of 2500. And now you can't really see it, but the number of configurations is reduced. And now I'm going to put in the signal to noise I need of 100. And now it has enough information that it's running the ITCs and all those different options and giving the integration time needed to reach that signal to noise. So I can search by the time. And you see I've got, these are the fastest options to reach that. One option for the north, one for the south. Let's say I pick one, but I'm not sure, which one should I use or which one is possible. And one way I can determine which one is the best is to look at the visibility. So I'm going to bring up the elevation plot here, and I could expand this a little bit to make it more visible. First, I'm going to, there's lots of information. As you can see, it has options to parallactic angle. There's the sky brightness calculations, which I'll turn off for now. So this is showing for tonight. It's the elevation as a function of time, and I can actually switch between local time, real time, UT time. I can also switch dates, going back and forth with these little arrow buttons, or I can bring up the calendar widget and select another day. It gives the calculation. So that's just for a given night. I can also look at the visibility of a semester by switching here from night view to semester view. And then for semester 22B, it's showing hours visible in a night versus date. So that's looking pretty good. I'm going to go back to night view for now. So this is the visibility at Gemini North. Actually, if I click on this observation for Gemini South, you see it's flipped this to GS. So you see the visibility at Gemini South. Obviously, given the definition, it's better in the north. So I'm going to select Gemini North. And I'm basically done. That observation is ready. Behind the hood, it was created a sequence that will reach that signal to noise. And if you don't need to make any other specific changes, this is ready to be submitted. And there's no need for any manual observation checking, phase 2 checks. And you can see that by looking at this beginnings of the advanced configuration panel. We're actively working on this. It's not complete, doesn't have all the fields as I showed in the mockup, but this is the place you get to view the sequence that it created. So at the top of the table was the acquisition steps, and then the same observation of the science steps with science and the associated flat. And you see there's a wavelength. This one does, yeah, there's a wavelength that are there as well. Again, in the advanced panel, you'll bet you, if you need to, you can change some details of that. As long as you're looking in the advanced panel, the sequence will still be created automatically with no manual checks are needed. There's also, if you run it, eventually there'll be a way to actually edit that table of sequence steps. But once you do it doing that, then it probably needs manual check. Okay, so I'm going to go back to, oops. Close this. I'm going to go back to simple configuration. Now I'm going to play a little bit with the constraints. This observation could be done, but maybe I want to relax the conditions a bit so that it's more schedulable. I can do that with this constraint panel here. So for image quality, now instead of percentile bin like we have now, which is a little hard to get used to, we're just going to accept image quality on target. So let's change that to 1.5 seconds. And now you see the ITCs are running again to give you an updated time estimate, where I can change the clouds to like half a magnitude of extinction. Same thing, it'll recalculate that. I can also change the constraints by going to the constraint view. So in here, I have everything organized by constraint set. So then as I showed in the mockups, if I click on the top of that, so all these are selected, then any edits I make to here are moved to all of them. So I'm going to change this image quality to 1 arcsecond, change the extinction 0.3, and that's a bulk edit. If I want to just change one, I can just select one of them, change this to 0.8, and then because it's a different constraint set, just pop that out into its own little grouping here. And if I click on this one, and I can actually do this, drag that up, drop it into there. That observation has now inherited the constraints of that group. Pretty easy. Then the targets view works the same way. And everything organized by target. Here I've got sort of a GMOS South and GMOS North options for NGC 3312. So again, if it's a little new magnitude here, I'll go in 14.2. And that's been changed for both of those observations. Again, if I want to just edit one, I can click on one of them. You see I have an option here by default. It's going to change just one of the observation, that one, and would pop it out into a different group, or I can select here and edit both of them. So now let's just go back to the observations view. A couple more features to make this more usable or user-friendly. For example, if you have questions about what some of these fields are and how you should edit them, We have the help built into the system now. You don't have to go to additional web pages and page through those. If you want to know what the image quality means, click on that little information icon and up pops this little tab with the help for that. We've also built in undo redo editing from the ground up. You have to do it from the ground up. That's one reason to sort of take advantage of this complete rewrite. So for example, if I change the image quality to 1.5 seconds, but maybe that takes too long or it doesn't suit me, I can change that to 1. Then I want to change my mind again, I want to go back. So I just undo that, or I can redo. So that's the basic features of Explorer right now. It's under active development. This is sort of what we call the production version of it. It's updated maybe once every month or two. So you stop back in a few weeks, it may look different or have different features. We have other development versions of this which are updating daily as the developers implement new features. So I'm going to go back to the presentation and talk a little bit more about some of the other applications. And then we'll get into, you can have a go at Explore. So one of the other apps that I mentioned is Observe, which is the application that actually executes those sequences that Explorer makes. Of course, this is mainly used by staff, but everyone who visits the telescopes, once that is possible again, we'll use this. It's a new version of our current web SecExec. And there's also, besides just the tool that you use to actually execute these sequences, is the interface going to be one of the interfaces to the automated real-time scheduler. So you see this is like the nighttime view. The current plan from the scheduler will be shown at the top here, showing what's happened and what it expects to come up based on the current conditions and any forecast. But then the point is, as things change, as TRO observations come in or weather changes, the scheduler will recognize that, run again, and then give you a new plan and give you an option for switching. So this particular example is a rapid TRO that came in that said, whoops, maybe you should really stop this observation and do this one right now. And then they'll give you some assistance on what you should do, either stop the current exposure and then switch, or just abort and go. And then one thing just to point out, that sort of got hidden. Each step in this has little exposure controls for running the sequence, pausing exposure, or aborting. So that's Observe. Again, the same basic layout and same kind of look and feel and interaction. Then there's Chronicle, which is the logging tool, which people will use extensively. That's when night and observing logs of the observers will enter the comments on data sets or comments at any particular time while the observation's going on. And these comments are related to data quality assessment. So this is where you get your obs log. So you go in here, say I want the log for this program on this night, and it will show you all these details of what happened. Also for the Gemini staff, it provides a nice view of what happened on a particular night, where there are errors or faults and the weather loss, and you can do the time accounting easily there. I also envision maybe it'd be a useful communication tool between day and night staff. So a timeline. Obviously, Explore and Observe are now under development. This Chronicle tool, we hope to start developing but sometime this year, about a 9-month development time. We expect to have Explore and Observe ready to be full GMOS long-split support by about September next year, which will allow us to start doing some early science. So we have these sort of early science test phase, which we call XT1, and we plan to do a special call for proposals for GMOS imaging and long slit about October next year, for observing in January 2024. So we'll have a special call for a certain number of nights. We'll use Explore and Observe just on those nights to execute those programs, put it through its paces, end-to-end test, and then continue with the development of the other modes and refining the features. This next phase is called XT2. So as each instrument gets supported, we want to hopefully, we were asked for some of the existing programs to be converted to the new system, try to give some incentives, maybe in time or other things for that. Until we're ready, should be complete by June 2025. And the system certainly has to be ready for Scorpio commissioning, and we want it to be all online by the time the Rubin alert stream starts up. So as we become more feature complete, we are wrapping up community testing. This is one of the first of those example of that. So besides just putting it through its paces and playing with it, eventually we'll be probably asking testers to fill in some questionnaires about specific features, do some mock use sessions, maybe some use interviews and quantitative use testing. So we compare the similar things that we did with the current OCS and make sure we're actually making improvements and get ideas for refinements. So it's good to see so many people here who at least have some interest in this. If you want to keep doing this, please let us know. So now we're at the interactive use part, but maybe I should pause to see if there are any questions on what we've gone through so far. Anything online? Okay, then let's dive into this.
Okay.
Oh, yeah, sorry.
There we go. I'm sorry if you said this and I missed it. Is Explorer intended to also work for the visiting instruments of Gemini, or is it just the facility instrument?
All instruments will have the visiting instruments as
Wonderful,
well.
thank you.
Observe will not work with the visitor instruments, because that's what makes the visitor instrument, but you'll still be able to define everything and explore. Okay, so then we can have, you can have at explore. So I've made a couple of Google Docs with some suggestions for what you can do, basically kind of repeat what I showed you in the demonstration. And there's a Google form here where you can get some feedback, give us some feedback. So I'll just sort of go through a few things on that. First, I want to make this a lot bigger, if I can. Oh, I see why. Okay, well, I'll put the links back up there so you can navigate to them, but I have most of the information here on the slides as well. So there's the URL for Explore, explore.gemini.edu. A couple of things to note is that right now we're using in-memory database, and everybody can see all of the programs in the database. So you can see, what I did in that first program. What I suggest is that everybody wants to try this out, make their own program, that's possible, and then do work in that. So you're not really writing over other people's stuff. So if you go up to guest user and manage programs, you can click on plus program and then type in a name like, and then you can work in that. Everyone else will be able to see that too, but that's okay, because sometime tonight, Heroku, which is the platform I use to run all this, resets itself, and because this is all in memory, it gets wiped out and reset every day. Just so you know that's what's going to happen. So then there's this Google spreadsheet where you can enter your name and any comments you have. I've got a couple of suggested exercises here. Basically, just go through the various features, log in with Orchid if you have one, create some observations and edit them and move them around. And if you really want to, there's a timed activity. So see how long it takes you to create this observation. We did this test with some people with the current OT, so we can see if it actually is faster with Explore. And so then I'll just leave this up so you have the URLs and that you have at it, and I'll walk around and just answer questions and see how people are doing.